How do you use MATLAB Simulink blocks and libraries? Imagine building a complex electrical system with just a few clicks. That's what MATLAB Simulink makes possible through its visual environment. It's like drawing a flowchart but for electrical engineering projects. When you open Simulink, you start with a blank model window. From there, you can access a variety of blocks organized into libraries. These libraries contain components like resistors, capacitors, motors, and power electronics devices. For electrical engineering, the Simscape Electrical Library is your go-to. It includes all the essential parts needed to model real-world electrical systems. To add blocks, you simply browse through the library and drag the component you need into your model. For example, if you want to simulate a motor, find the motor block in the library and drag it onto your workspace. Each block has parameters you can customize. For a resistor, you might set its resistance value. For a power converter, you can adjust switching frequency or voltage levels. You can do this by double-clicking the block and entering your desired values. If you want more flexibility, you can link these parameters to MATLAB variables. That way, you can easily change values and see how the system responds. Connecting blocks is straightforward. You draw signal lines between them, which representing the flow of electrical signals or energy. For instance, connect a voltage source to a resistor, then from the resistor to a scope to observe the voltage across it. Adding input sources like voltage or current sources is simple. You just drag them from the library and connect them to your circuit. For outputs, scopes or data loggers help you see how your system behaves during simulation. Once everything is connected, you hit the Run button. Simulink then performs the calculations behind the scenes and shows you the results. You can analyze waveforms, voltage levels, or current flow. If you're designing a control system, you can add control blocks from the control library, tune parameters interactively, and even generate code for hardware implementation. This is especially useful in electrical engineering projects like designing inverter circuits or electric vehicle powertrains. You can also integrate MATLAB scripts to automate your simulations or analyze data more deeply. For example, you might write a script to run multiple simulations with different parameters and compare the results. This makes your workflow faster and more efficient. In practical terms, using Simulink blocks and libraries helps you move from just understanding components to building complete systems. Whether you're modeling renewable energy setups or power distribution networks, the graphical approach makes it easier to see how everything fits together. It reduces the need for complex coding and speeds up your development process. To sum up, you start by opening Simulink and creating a new model. Then you select the right blocks from libraries like Simscape Electrical. Customize their parameters, connect them logically, add sources and sinks, and run your simulation. You can also use control blocks and generate code for real-world applications. This method supports your professional growth by giving you practical skills in designing and testing electrical systems efficiently.